ellipse video, we're going to graph an ellipse that is centered at HK. So we're sliding the ellipse now horizontally and vertically. Let's take the first example. So we're going to graph this equation, identify the center, vertices, and foci of the ellipse. First, we start with the center, HK. We know that this number is H here, and this number is K, so we take the opposite. So we put HK on the coordinate system. Remember, in an ellipse, A squared is always larger than B squared, or A is larger than B. We can also say A larger than B. So A squared in this case is 25. That means A is 5. And the major axis has a length of 2A, always. The minor axis is the smaller denominator, and its B squared is 4. That means B is 2. That means the length of the minor axis is 2B, which is 2 times 2, 4. Now, remember the vertices are A units from the center. Since A is under the X in this right here, the A squared is under the X, we know that the ellipse is horizontal and the major axis is horizontal. So I count from the center A units to the left, A units to the right, and then I place the vertices. So we count. A is 5. We're going to count 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And then we're going to put the vertices. The co-vertices are always on the minor axis, and B in this case under the Y, so we're going to count from the center B units up, B units down to put the co-vertices. So since B is 2, I'm going to count 2 units from the center, 2 units down, and put the vertices. So I count 1, 2, 1 co-vertex is going to be here, and another co-vertex is going to be here. So let's put them on the graph. And now I can graph the ellipse with the vertices and the co-vertices, and I still need to find the foci. The foci are C units from the center. Now, to find C, there's an equation that I have to use. C squared is equal to A squared minus B squared. So C is the square root of 21, which is about 4.9. So from the center here, which is already at 2, so I'm going to count from the center, which is already at 2 horizontally, 4.9 or root 21, and from here root 21. So I get from the center here 2 plus root 21, 2 minus root 21. Remember, the foci are always on the major axis. And that's where I put the foci. You can use the square root 21 as 4.9. So 2 plus 4.9, 2 plus 4.9, that's 6.9, negative 3. 2 minus root 21, which is root minus 4.9, that's negative 2.9, negative 3. Let's continue to take examples. So this ellipse is not written in standard form, so I'm going to have a 1 right here. I have to have a 1 right here. I need a 1. So I'm going to divide every term by 36. So I'm going to divide 9 times x minus 9 squared by 36. I'm going to divide 4 times y minus 2 squared by 36, and I'm going to divide 36 by 36. So when you divide 9 by 36, that's how you get the 1 over 4. So that's 1 over 4. When you divide 4 by 36, that's how you get the 9 here. And of course, you need a 1 here. First, the center of the ellipse is HK. That means I have the center at 9, 2. So we put the center at 9, 2. Erase this. Now, remember, in an ellipse, A is the bigger denominator. Always A squared is larger than B squared, or A is larger than B. In this case, A squared is 9. That means A is 3. And the length of the major axis is 2A. So 2 times 3 is 6. So I have here 2A. The minor axis is always the B squared. I get the minor axis length from the B squared term, which is the smaller denominator. Since B squared is 4, that means B is 2. And the length of the the minor axis is 2B, which means 2 times 2, that's a 4. Now, this ellipse has the A squared under the Y, which indicates the ellipse is a vertical ellipse, which means the major axis is vertical. So from the center, I'm going to find the vertices now. From the center, you're going to count A units up and A units down. In other words, 3 units up, 1, 2, 3, and then 1, 2, 3, 3 units down, and you put 1, 9, 5, and 9, negative 1. So you put the vertices. Now, to find the co-vertices, or to find the coordinates of the co-vertices, you're going to count from the center B units to the left and B units to the right. Since B is 2, so you count from the center 2 units here and 2 units here. And I put the co-vertices. So from here I have 1, 2. So I have one of the co-vertices at 7, 2. And if you count 1, 2, that's 11. That's 10. You need one more here. That's 11, 2. So I put the co-vertices, and you can graph the ellipse. We still need to find the coordinates of the foci. The foci are C units from the center. How do I find C? You use the equation C squared equals A squared minus B squared. So C is root 5, which is about 2.2. So from the foci are always on the major axis. So from the center, which is already at 9, 2, you count root 5 up, root 5 down. That's going to affect the y, okay? So one of them is at 9, and this is 2 minus root 5, and one of them is 2 plus root 5. So the first focus is at 9, and this point, if I do 2 minus 2.2, that's about negative 0.2. And the second foci, it's at 9, 2 plus 2.2, 2 plus 2.2, that's about 4.4. And I put the foci. Let's continue to the third problem. Find an equation of the ellipse with foci negative 3, 4 and 9, 4, and the length of the major axis is 14. So let me put that. It's best if you have a coordinate system, and it's easier if you put the given on the graph. So let's put the foci. We know the center of the ellipse is the midpoint of this segment joining the two foci. So the center is going to be in the middle. Please use the midpoint formula. Don't rely on the graph to find the middle, because that middle might be some decimal right here. So rely on the midpoint formula. So the center is between the two foci, and the midpoint formula gives you the coordinates of the midpoint. That means, so if you apply this as x1, y1, x2, y2, you can find the midpoint as 3, 4. So that's the center of the ellipse. Since the ellipse has the center and the foci are horizontal, that means I'm going to have a horizontal ellipse. In other words, the major axis is horizontal. The major axis has length 2a. So since this is given right here, it's 14. 2a is 14. That gives you a. So divide by 2, that's a is 7. So a squared, this number right here, the 49, that's a squared. A squared is 49. That will appear under the x in the equation. In a horizontal ellipse, in a horizontal ellipse, the a squared appears under the x. And we have the equation c squared is equal a squared minus b squared. And I can easily now solve for b, or b squared. So b squared is 13. I put the a squared, which is 49, and the c squared is already given. So b squared is 13. A squared is under the x. B squared will go under the y. And the equation of the ellipse, x minus 3 squared over 49. Remember, the center is right here, the center of the ellipse 3, 4. And the required equation is x minus 3 squared over 49 plus y minus 4 squared over 13 is equal to 1. You don't need to graph the ellipse. It's helpful though to have the given on the coordinate system. It helps me see if the ellipse is horizontal, it helps me see the foci and the co-vertices. So again, no need to graph the ellipse. You're required to just find the equation. And this is the required equation.